today what we're going to do is we're going to talk about solving equations. This should be a fairly easy lesson. We've been solving equations for years. And so the first thing we're going to do is we're just going to look at this. It says write an algebraic expression to represent each verbal expression. And so we're going to do a couple of these, and then we'll get to solving the equation. So let's look at this one. It says 2 more than 4 times the cube of a number. 2 more than, what does that mean? Plus 2. Okay, so I've got plus 2. 4 times the cube of a number. 4 times n cubed, perfect. That's it. 4n cubed plus 2. Okay. Next one, the quotient. What does quotient mean? Quotient? Divide. 5 less than a number. So what would 5 less than a number be? Actually the other way. Whenever we have less than always means that it comes after. Okay, so n minus 5, and then it says the quotient of 5 less than a number and the number 12. So whenever it says less than, you always put the variable and then put the less than after. Okay, the cube of a number, how can I symbolize that? N cubed. Increased by 4 plus 4 times the same number. Okay. Times by n. And then let's look at the next one. 3 times the difference of a number and 8. So difference, what does difference imply? Subtraction, negative. Okay, so difference of a number and 8 would be what? N minus 8, and then what's 3 times that? Parentheses. Does the 3 go before or after? Okay, it can go both. It's generally accepted to go before though. Okay, if you do it after, it kind of looks odd. Kind of like the one up here above in orange. I probably should have put the N in front and written it this way. So anyway, so think you can handle that? Okay, so here we go. Write a verbal sentence to represent each equation. So 6x equals 72. Now we're going to write out in words. So this would be 6 times a number equals 72, or what's another word for equals? Is. 6 times a number is 72. So equals, you can use the word is. Otherwise, you could have put 6 times a number equals 72. The reason why I put is because it's shorter, less writing. Okay. So let's look at another one. N plus 15 equals 91. Okay, there's a couple of them. You could have 15 greater than a number is 91. You could have a number plus 15 is 91. You could have the sum of a number and 15 is 91. So there's 3 different ways I've said. So I will go with the one I heard first. No favorites. A number plus 15 is 91. Okay, let's look at the next one. G minus 5 equals negative 2. The difference between a number, finish it for me, and 5, good, finish, is negative 2, very good. Otherwise, you could have put, as I was hearing said back there, a number minus 5 is negative 2. Any of those work? And last but not least, woo, this is a good one. How about twice? Just because that kind of sounds academic. Twice a number is, or instead of is, maybe what should we put this around? Equals, yeah, that would probably sound better. Twice a number equals
The same number squared.
that number squared.
Minus 4.
Perfect. That number squared minus 4. Okay? So think you can handle that? So, we've translated verbal expressions into mathematical expressions. Now we're translating mathematical equations into words. And so last but not least, we're going to review reflexive, symmetric, and transitive and substitution properties. Reflexive. Remember, reflexive means 1. Symmetric, 2. Transitive, 3. Now this is taken from your book. Okay? Now this is how I remember it. R, S, T. R is 1, S is 2, T is 3. It goes alphabetical. So RST, 1, 2, 3. Kind of even rhymes. So now, for those of you wondering, well, what do you mean 1, 2, 3? Let's go ahead and look. Notice here when I talk about reflexive, it says for any real number, A equals A. 1 equals 1. For symmetric, it says A equals B, B equals A. What does that symmetric look really familiar, or really similar to that we looked at yesterday? What property? Commutative, right, with 2, very good. Okay, so that symmetric is real close to commutative just because it talks about 2 terms, A to B, B to A. Transitive, A to B, B to C, so then A goes to C. Now that should make sense because when you think about it this way, imagine here, let me go ahead and use a pen here. A goes to B, B goes to C. So A goes to B, B goes to C. So really, you know then that A has to go to C. It's kind of like saying, I went to York, couldn't find the shoes I wanted, so then I drove to Lincoln. When essentially, really what you did is you drove from Strasburg to Lincoln. Okay, that's the same distance. Strasburg to York, York to Lincoln, Strasburg to Lincoln. All right, so let's look at this next one. It says, name the property illustrated below. 3A minus 4 equals B, and B equals A plus 17. Then 3A minus 4 equals A plus 17. So let's look at what I did. This equals this, this equals this, this equals this. So what is that going to be? Transitive, good. Now, some other people argue that that could be substitution. It's really transitive just because it fits transitive so much better. Let's look at this next one. 2G minus H equals 62 and H equals 24. Then 2G minus 24 equals 62. So let's look what I've done. I've taken 24 and I've put that in place of H. So what do you get? Substitution. Good. Okay, now what we're going to do is look at solving some equations. Now first of all, in order to solve some equations, we're just going to review this. Okay, by now you've seen these over and over again. This just allows us to solve those equations. Basically what it says, if you add something on one side, you have to add it on the other side. If you subtract something on one side, you have to subtract it on the other side from the original equation. Likewise with multiplication. Multiply on one side, you got to multiply on the second. Divide on one side, you got to divide on the second. Okay, so let's jump in with some examples here. Basic equation. X minus 3.24 equals 42.1. So on your expressions, I want you to go ahead and type that in. Type the solution to that in. Yep, and the answer is 45.34. Very good. So let's go ahead and look back at the original problem. I've subtracted 3.24. So to undo subtraction, I'm going to add 3.24 to both sides. That's the additive property of equality. Whatever I add to one side, I have to add to the other. Cancel these, and I get x. On the right side, if I add those, I get 45.34. Okay, let's look at the next one. -5/8 x equals 20. -5, -32. Now, for those of you who wondered, it looks like some of you forgot the negative sign a little bit. This is multiplication. So if we remember, what undoes multiplication? Division does. So we could divide both sides by -5/8. But that kind of looks kind of weird. So the easiest way is to just multiply by the reciprocal of 5/8. Okay, and so what I like to do, instead of doing that division, I sit there and say, oh, you know what I'm going to multiply by? I'm going to multiply by -8/5. I'm going to multiply this by -8/5. On the left side, 8's cancel, 5's cancel, negatives cancel, leaves me with x. On the right side, 5 goes into 20 how many times? 4. So I have 4 times -8, which is -32. Okay, next one, distributive property. And the answer is -1. Good. So what we need to do here is distribute. So when I distribute the 5, I get 5x plus 15 equals 2, equals, try that again. 5x plus 15 plus 2 minus 2x, that equals 14. Add like terms, you get 3x plus 17 equals 14. If I now subtract 17 from both sides, I get 3x to equal -3, and so then x equals -1. Okay, let's look at the next one, very last one. Be careful on this one, okay, with the negative. Times 2x minus 1 minus 4 times 3x plus 1 equals 2. One more. And the answer is -1. Okay, where the -1 comes from is when you distribute the 2, you should get 4x minus 2 minus 12x minus 4 equals 2. Now if you go ahead and combine like terms, you should get -8x minus 6 equals 2. When you go through and solve that, you'll get -8x to equal 8, x equals -1. Assignment for Monday, pages 22 through 23, 22 through 42. Have a lot of time right now where you could get done with that.